This is R.D. Sharma solution, class 12, chapter 19. We are taking exercise 19.8, indefinite integrals. 1 minus sin x divided by x plus cos x. Now if you watch this x plus cos x denominator very closely, you will find that the differentiation of the denominator is exactly the numerator. So t is equal to x plus cos x. If we put this, dt by dx is going to be 1, cos x will be minus sin x, 1 minus sin x. So this 1 minus sin x into dx, if you take this dx on the right hand side, cross multiplication, what you find is the numerator is actually d when we take t, and denominator is x plus cos x, which is t. So dt by t, and this is simply log base e. So let us write it as ln, modulus of t. What is t? T was x plus cos x. So let us write x plus cos x and along with the constant of integration. This is your final result. Now this is the way you are going to put this thing on a paper using your pen, and please write lead, putting all this has to be done. Now this type of question, there are a few questions of this same sort. Even if you write this b plus c raise ex into some t, you won't get anything in the numerator. But one thing is very clear, when e raise x comes, this e raise x differentiation is e raise x only. Integration also is same. So if you divide numerator and denominator by e raised to x, so I am dividing everything by e raised x, numerator, denominator included. So this e raised x, when it goes up, it will become e raised minus x. And there will be negative also when you differentiate. So with this trick we are going to apply here. E raised x goes up. This goes in the numerator, it will be e raised minus x. This is b, e raised x goes up, it will be e raised minus x. Then you have c, this you can just cancel these out, so only c will remain. So what do you get here? When you take e raised minus x as t, this dt by dx will be e raised minus x, and differentiation of negative x will be negative 1 or negative. So this, if you take this, let me write it so that I can show you what is the numerator and what are we getting when we put this e raised minus x equals to t. So e raised minus x into dx is negative dt. Just replace this by negative dt here. A you can take outside because it's a constant, and this negative also minus dt, so negative I'm taking outside. So dt divided by b, e raised minus x is t plus constant of integration. So we have this integration of 1 by ax plus b always gives you, this is very important in this exercise. It gives you 1 by a ln log base e modulus of ax plus b if ax plus b is only in the denominator. So just assume that a is b here, b is c here, and there is a conflict here which is the c, constant of integration. I'm just going to deal with it just now. So what will be the result? The b will go down, that is 1 by a, as you saw in the actual formula. So this b goes on the denominator, ln bt plus c. Now this c, if you are writing it, you have to write this constant of integration as the capital one. So almost done. Only t has to be, we have to get back to the original thing, which is our e raised negative x. So negative a by b ln b raised b into e raised minus x plus constant of integration plus this capital C, which is denoting the constant of integration. This is how you are going to write it, dividing numerator and denominator by e raised x, putting I, capital I, what you have written here, and since 1 by ax plus b integration is this thing, all this has to be written, right? So the next question is almost similar to this question. If you understood this, this one will be very easy to you. What we'll do here is, we will divide everything by e raised x. So e raised x divided by e raised x plus 1 by e raised x. What do you get here? E raised x goes up, e raised minus x. This gets cancelled, so you have 1 plus 1 by e raised x is e raised minus x. Now what do you get here? Just put e raised minus x equals to t. That's very obvious now, because previous question, if you followed it, this is dt by dx, e raised minus x. Differentiation of negative x is going to be negative 1. So we need e raised minus x into dx. So when you cross multiply, e raised minus x into dx is equal to negative dt, and the numerator is going to be negative dt. So e raised minus x into dx, it is negative dt, so negative comes here, dt, and 1 plus e raised minus x goes in the denominator, 1 plus t. And this already we have seen in the previous question also, that it's a simple integration result. I is equal to, let's write the result, it's just ln, that is log base e. Negative was outside already. 1 plus t, this goes up, and with the it is contained inside the modulus sign plus constant of integration. One more thing is remaining, which is t. Let's get back to our original version. An original version says e raised minus x was assumed to be t, which has to be replaced by us. T is e raised minus x, all other things remains the same. So this is the result we were talking about, and all this let, putting, and even if you want to write that formula which we studied in the previous question, that has to be put in here. Cot x divided by log sin x. Now this is very straightforward question because it's very clear. Log sin x, if you put it as t, you are going to get cot x dx. That is, if you write t equals to log sin x, if you put or let dt by dx is going to be equal to 1 by sin x here, and sin x will be cos x, differentiation. So you get cot x on the right hand side, dt by dx, dx you can take on the right hand side, will be cot x dx. So the numerator, it goes, and this will form a dt. So integration of, what do you get? Cot x dx is dt, and in the denominator log sin x was taken as t. So this integration becomes simply ln modulus of t. Log is base e, because it's given in the question log, so I'm writing log. When it's not given, always write ln, not log. Since the question is saying log, we are writing log. Now let us take the modulus of t. I'm just writing the actual thing, log sin x, just trying to get rid of one more step. And there is an intermediate step also, okay? I'll just show you. But this is the final result. So this is the solution we were talking about. All this language, English language, in order to make it understand to your examiner, you have to write it by yourself. Now this is a very straightforward question. Okay, you can just do it by yourself. Go ahead. And those who want to actually understand, let's do it in a quick manner. T equals to e raised 2x, dt by dx will give you e raised 2x. The differentiation of 2x will be 2. So this is 2 into e raised 2x. So in order to replace e raised 2x into dx, we'll get dt by 2 equals to e raised 2x into dx. E raised 2x into dx, dt by 2. So the upper content we already got. Let us replace it by dt by 2. Now this is 1 by 2. I'm taking it outside. Always take the constant outside. Dt is there, e raised to x is nothing but t minus 2. It's quite straightforward now. We have done a few questions like this. So 1 by 2 ln, because there is no log given. So always type ln for it. T minus 2 plus constant of integration half ln. T has to be the original thing, which is e raised 2x minus 2 and plus constant of integration. This is your final result. Okay, this is what we were discussing about. See, I do it in 2 or 3 steps, but you have to write all of it, because what you write is what being understood by the other people. 2 cos x minus 3 sin x, 6 cos x plus 4 sin x. Now those who have done a question like this, they will see and they will take 3 common from the denominator. So you'll get 3 and 3 2s are 6, and you can take 2 common because you need the numerator, right? So this is a 3 cos x, and you take 2 out, it will be 2 sin x. So when you differentiate this 3 cos x plus 2 sin x, you are going to get the upper result, that is the numerator, directly. But my question is that I know it. How will you know? You are learning right now. Okay, I know everything. Most of the thing I know because I've done it. So I will go along with you. I will not take this anything common. I will do it with what we have. That is, I'm just cancelling it out. Those who know, they can just go ahead. But I am writing without taking anything constant, just 6 cos x plus 4 sin x. This is specially for those students who really want to understand things, and they should know the trick to be understood very well before attempting this question. So just take the denominator 6 cos x plus 4 sin x. This differentiation will be negative 6 sin x, 4 sin x will be cos x. And now here, when you see 2 cos x minus 3 sin x, you need that, right? Now you can do it here, because now it's quite evident that you need 2 cos x minus 3 sin x. You can get it from here. So just take 2 outside. You will get 2 cos x. This is going to be minus 3 sin x. So this is dt, this is dx, this d2 goes in the denominator. dt by 2 is 2 cos x minus 3 sin x dx. This is dt by 2. Now what do you see here? It's the same thing which we were expecting, which we wanted to know. Alright, now you can do it. Integration of the numerator is a dt divided by 2, so half I am taking outside. 6 cos x plus 4 sin x, and this is in the denominator. You have a t in the denominator. Only there is a catch of this half. You'll see, because when I'll show you the printed result, that will be different, but the answer will remain same. Half, the approach will be different. Ln, what is t? 6 cos x. Let us take 6 cos x. Don't worry about that. You will get a way to actually get it the way the book or the r.d.sharma solution is prescribing you the result. So 6 cos x plus 4 sin x plus c. But this is not the actual result. Why? Because when you want, because there has to be some matching. So this 6 cos x plus 4 sin x, you can just take 2 outside right now. If you keep it like this, that this is also a complete solution. I'm just saying that this is the result. But in order to match the answer which r.d.sharma or the book has provided, we can take 2 constant from here outside. When you take 2 outside, what you are going to get? 2 into 3 cos x plus 2 sin x. So log a into b. What is log a into b? Log a into b is log a plus log b. What is log? First one log 2. The second will be log 3 cos x plus 2 sin x. Now just understand it very well. I'll show you how this 3 cos x plus 2 sin x will be the final result. Half log ln basically 2 into 3 cos x plus 2 sin x, and then constant of integration. Now just separate them out. Log, as I just indicated you, log a into b was log a plus log b. Again I am telling you because this is very important. These are the results which will come all the way, all through. So these needs to be on your tip. So just multiply this half and separate them out. Half ln 2 plus half ln 3 cos x plus 2 sin x in the modulus. And what about half log n? It's a constant. You can just add it with the final constant. Ln 2 by 2 is a constant, so you can just add it with the constant. So the final result is half ln 3 cos x plus 2 sin x plus constant of integration. So if you take t 3 cos x plus 2 sin x, this step which is log a plus log b, that you can get rid of, or that you can bypass. So this is what I was talking about. So you can take these 3 cos x plus 2 sin x only when you learn this question. You have done 2-3 questions like this. Then you are aware, what to take, what not to take. But if you are not aware, then the way I told you, you can go about it. What do you see here? X square plus sine 2x plus 2x. When you differentiate this denominator, you are going to get the numerator by itself. So x square will be 2x, sine 2x will be cos 2x with a 2 also. And 2x differentiation will be 2 only. So what I am trying to suggest here is just take this denominator directly as t. When you take x square plus sine 2x plus 2x, dt by dx is going to be, x square will be 2x, sine 2x will be cos 2x, then the differentiation of 2x will give you 2, so it will be 2 cos 2x. Differentiation of 2x is going to be 2. So when you take 2 common, you will get x plus cos 2x plus 1. Now this x plus cos 2x plus 1 is nothing but what you are going to get in the numerator. So dt by 2 is this one, cos 2x plus x plus 1 into dx. This is what you get in the numerator. So how easy it has become. This is dt and this half goes here. So what you have here, you have taken already x square plus sine 2x plus 2x as the t. So dt by t, it's just half ln modulus of t. That's the direct result which we have been doing until the 26 questions. So x square plus sine x plus 2x plus constant of integration. This is your result. T was x square plus sine x 2x plus 2x. So this is the solution which you are going to write by yourself. Now this question 1 by cos x plus a cos x plus b. Now here again this is a separate question. It will not follow all the rules and regulation that we have just completed in our past 7 exercises we have done. At the 8th exercise we are on to. This x plus a and x plus b shows you something. That is, how can we make it easier? Come all things in the numerator, bring everything in the numerator, cancel things out, make it easier, and try to conclude with a very simple result that is possible in integration. I am writing cos x plus a into cos x plus b here, but I'm introducing something, and that introduction is sine. Now what do you see inside? X plus b minus x minus a. What are you going to get? X gets cancelled, you get b minus a. So x plus b minus x plus a you can write, because x plus a and x plus b already we have in the denominator. So sine b minus a, multiply numerator denominator by sine b minus a, but this b minus a should be written like this: x plus b minus x minus a, x plus a, sorry. Similarly, if you have multiplied in the numerator, denominator also should have sine x plus b minus x plus a. Now you will just ask a question, why are you doing this? Why do you do this? Isn't there a simple solution? I'm afraid not. So this sine b minus a is a constant. That's why you don't have to worry about the denominator. You can just separate this out from the actual integration. Sine b minus a goes out of the integration sign. This sine x plus b minus sine x plus a is sine a minus b. Now you have to apply the formula of sine a minus b. Okay, sine a cos b minus cos a sine b, like this. So what is a here? X plus b. What is b here? X plus a. So sine a, that is x plus b, cos x plus a minus cos a sine b, cos x plus b sine x plus a. You can just exchange or change the position, it's up to you. Eventually there is cos x plus a and cos x plus b in the denominator. That is important because there will be a lot of calculation and cancellation which will take place. So this cos x plus a and cos x plus b, just put this in the denominator for both the terms which we got just now after expanding sine a minus b formula. So this cos x plus a, cos x plus b in the denominator. Integration is already there, dx is already there. Okay, don't forget about that. Cos x plus a cancelled out, cos x plus b cancelled out from first and second term respectively. Now sin x plus b by cos x plus b is tan x plus b. Similarly, sin x plus a divided by cos x plus a is tan x plus a. So these two separate terms integrate different in a way, but the result remains the same because it's just tan something dx. So what is the tan theta integration? It's log sec theta. So log sec x plus b comes here. Here log sec x plus a comes here. But you know the formula of log a minus log b. What is log a minus log b? You can always write it as log a by b. This goes log, this is sec x plus b by sec x plus a. Now you can make it easier, but I can assure you that this is the solution. This is the final solution, but just make it as cos now. Sec goes up, it becomes cos. So sec x plus a goes up, it will be cos x plus a. Sec x plus b comes to the denominator, it becomes cos x plus b. So 1 by sine b minus a is already there, was already there. So these two are the result, whichever you want. You can just stop at this one, but if you want more adventure, just do the last one also. Okay, now you understood why we have taken sine b minus a. Why did we multiply it in the numerator and denominator? Why did we write b minus a as x plus b minus x plus a in order to get this? So this is the result I was talking about. It seems typical, but not. The way I explained you, I hope you can solve these kind of question if it comes to you in the later part of your life. This will take in the next discussion. Till then, thank you so much and have a good one.